Okay, so any speaker from the last four talks, please feel free to turn on your cameras and get ready to answer questions. We've got a lot of great ones in the chat. So without further ado, I'll jump into the first question, which is for Jack from Alexander Miller. Do you have any, from your lessons learned from all of your Apollo experiences, do you have any, I'm going to summarize the question here, specific recommendations for the fact that we're going to be conducting missions at the South Pole of the moon?
Now, operationally, the big difficulty is going to be lighting, I think. You not only have extensive shadow, but I believe you'll see a much less backscattered light into areas. I use backscattered light a lot. For example, at Station 6, you can see very well in the lower latitudes, but in the high latitudes, I'm not sure that's going to be as effective. And so having auxiliary lighting is going to probably be very important. Also, just remember, I put it in the chat room, but remember that the crew, at least for 17, and I was on 15 as a backup crewman, the crews were deeply involved in the pre-planning of the mission and bought into that planning, and that's why I think they were so successful. And even though they had to be revised at time, as Jim has pointed out, still that buy-in is a very important part of the missions, and why you've got to be reluctant to change the plan. Because that's important. The plans are based on the knowledge that you have, and we're going to have so much more knowledge for Artemis than we had for Apollo. I think any revised planning is going to happen between EVAs much more so than during EVAs, unless there are issues like Jim outlined that are equipment or other problems.
Yeah, I just add to that if I could, I would just add to that again, think Apollo 16. This is not, we're not going to be dealing with specific areas which we can say, oh, that's the edge of a lava flow or anything like that. We're on the rim of the South Pole Aitken Basin, and there's dozens of craters that are dumped ejected, and it's going to be really difficult.
Well, it may be difficult, but there are ways in which you can deal with those difficulties if you have the kind of photographic resolution and imaging of various kinds, radar, you name it, that we should have. For example, the way you sample these massifs is with boulders, and boulders that leave tracks and tell you where they came from. They're just, we knew that for Apollo 17, but we really didn't realize that it was going to be so successful in actually sampling the stratigraphy of the North Massif. Now, in the case of the South Massif, we didn't have tracks. And that was because of that avalanche primarily, although there is evidence that the tracks that were there were old enough to disappear. So again, the pre-planning is extremely important, as are the field excursions. I think it's much more important to emphasize simulations in the field, as we had for the last three missions primarily, although some for Apollo 12 as well, emphasize those rather than classroom. I get these guys out into the field and they'll learn a lot more than they will in the classroom. Now, one exception to that is that everybody should actually be able to handle the lunar samples and handle Mars meteorites. You need to have that hands-on feeling for what you're going to be looking at when you get there.
And just a quick addition to that is that as Jack says, if you could get boulders, that's great. But that translates into starting to convince the managers and engineers that you need to land in places that have boulders. Okay, that's not going to be what they're going to want to do. Okay, so you need that's just a good lesson to factor into the overall communications in the science and engineering synergism.
Well, boulders are important, but regolith is important as well because it contains the fragments of other boulders.
Okay, thanks. Let's move on. This was a question from Jack Schmidt to Renee, but perhaps some of our headquarters colleagues and maybe Jake as the HEO rep could answer this. Is there any way for NASA to have a specific selection for field geologist astronauts so that every lunar and Mars mission has that expertise and experience?
Yeah, I can comment on that. I mean, I can't speak directly to the specific criteria on any selection crew for the astronaut office, but the most important thing we can do is clearly define objectives that the astronauts who will be parts of those classes will be asked to address. We're not abandoning ISS. We're not, we're building up commercial crew activities at this time. So there's a breadth of potential objectives and activities that these folks are going to be asked to do. So what we've been asking from headquarters is to go ahead and get these studies done so we define these lists of objectives that are related to science activities for the lunar surface, because that's something we can then point at that can be part of the rationale for influencing how crew members are selected. So that's why it's urgent that we get these things done as soon as we can.
But Jake, if I just could interject, we know these are exploration missions, right? Sure, there are other things that added on. I had to deploy an ALSEP, for example. But having 10 or 15 years experience in the field is extremely important when you're doing exploration. And I don't know why you have to convince anybody of that at the headquarters level. You really need to seriously consider a selection of experienced field geologists so that you can have them on every crew. It's exploration, for crying out loud.
Yep, I do not disagree with you, Jack. I think you know that I agree with what you're saying there. The key is for us to go ahead and document what you're saying right now. I can certainly make all these arguments on a day-to-day basis, but having that backed by recommendations and documents certainly will help. The other thing I'll note is that the most recent selection classes have increased the number of scientists that they're bringing on board.
I didn't say, Jay, I'm sorry, I didn't say scientists, I said field geologists. There's a big difference.
Yep, I hear what you're saying, Jack. Absolutely. I'm glad that you raised the question so that we can document it here and make sure that we carry it forward. We have brought in astronauts that have geology experience. We have several in the astronaut office right now. And I'm sure that based on the recommendations we're making here, that can only help us try to add to that group.
Okay, thanks, guys. A question for Renee. To meet science objectives, do you believe that there's a likelihood of the crew bringing along refrigerated sample return equipment for the recovery of lunar polar ice samples?
So, yeah, 2 points on that. The science definition team did make a recommendation for the Artemis missions to have some sort of cryogenic sample return capability. Of course, for the first missions, a big part of what we'll be able to accomplish is dictated, again, by the capabilities of the human landing system, which at least initially is somewhat mass constrained. And so if we don't have the ability to bring those types of canisters because they are more massive, that's a capability for future missions to hopefully meet that technological challenge.
Thanks, Renee. Another question for Jack. What do you think was the most important learning curve from the Apollo EVAs that should be taken into account when planning for Artemis EVAs?
Well, I think one of the things, again, I don't want to just talk about things I was involved in or partly responsible for, but getting the crews involved in field simulation was very important, not only for scientific return, but for the confidence in each other that was built up in those simulations. For example, in Apollo 17, we had Gene Cernan was commander, and the science side of things, he relied on me to make decisions on what we ought to do at any particular station. That was very important to build that kind of trust in each other's abilities. And that really started with Al Shepard agreeing for that kind of training to take place for the Apollo 13 mission if Jim Lovell agreed and Fred Hayes wanted to do it. And they did. And they influenced crews down the line to undertake that kind of mission simulation training. That was, I think, very important. That learning curve made all the difference in the world. Lovell convinced Dave Scott that he should do it, and that made a big difference in what Jim has described for the Apollo 15 mission. Dave bought in, Jim Irwin bought in. Getting these guys, these astronauts are not geologists, to buy into that kind of exploration and training is extremely important.
Thanks, Jack. That's great. And you guys are making Jose and I's job even easier by kind of isolating our discussion points today and a few key findings. So thanks to all of you for that. Unfortunately, we're out of time and we got to move on because we're running a little bit behind. So I encourage all the speakers from the session to skim through the chat because there are some great questions in there that I think you could comment on in the chat. And we can also, I'm taking notes and we'll bring this stuff up in the breakouts as well. So plenty of other time to discuss this. And we'll pick back up with the historical and current perspective session at 12:35 Eastern. It's a shorter break this time around, but I think that's okay given we're only an hour in. So see you guys back in about 10 minutes. Thanks, everybody.